Great day, everyone. This is Jason Santos, and for today, we will continue the discussion of operations research. And we are now on the second, or actually the third unit, transportation and assignment problems. So, for this discussion, we will cover the first part actually, because there are a lot of ways on how you can compute for the transportation methodologies. So, we will have the transportation method explanation and then two procedures for evaluating unused squares, and then the northwest corner rule method are the first methodology that we will use in computing or solving for transportation problems. So first we have to understand the nature of transportation problem, and it is concerned with selecting routes in a product distribution network among manufacturing plants and distribution warehouses, or among regional distribution warehouses and local distribution outlets. So we're very familiar with issues with transportation. Even here, locally in the Philippines, we can see that transportation is a problem, not just for the mass public who are traveling, but also for companies, as they would want to maximize each trip and save costs. Okay, so typically, the quantity of goods available at each supply location or origin is limited, and the quantity of goods needed at each several demand location is known. So we know the demand, and then the supply is also known, but it is limited. So the usual objective in a transportation problem is to minimize the cost of shipping goods from the origin to the destination. Okay, that's why in my previous examples, as you can see, some companies, when it comes to logistics, are much more efficient and they charge lesser. Like for example, JNT Express, as compared to Lalamove or Grab, which is charging a little bit higher. Okay, because with JNT, they are applying the concept of economies of scale. Okay, so there are only few trips, and then there are a lot of quantities that are being shipped. Okay, so that's just an example, and we can actually see that happening in any type of um, logistics, okay, or shipments, whether in the Philippines or other countries. Okay, so generally, the transportation model can be extended to areas other than the direct transportation of a commodity, including, among others, inventory control, profit maximization, employment scheduling, and personnel assignment. Okay. So what we are trying to avoid is for one company to go to multiple destinations. Okay, just like this elaboration. Okay, multiple destinations without a clear path. Okay, it's like you are going out to travel and then you do not know where you are really headed to. You are just trying to see where you will be going while you are on the road, so that's not efficient. Okay, you're wasting your time, you're wasting gasoline, and you have not made up your mind. Okay, so that is what we are trying to avoid generally. Thus, we have several ways of computing for the efficient transportation methodology, and one of which would be the northwest corner region, which we will discuss in a bit. Okay, but first, let's segregate, okay, the two types of transportation problems. So the first one would be the balanced. Okay, when you say balanced, you can see that the supply is equal to demand. And then, of course, opposite that, you have the unbalanced, wherein the supply is not equal to demand. So here we have an example of a tabulated transportation problem. So here you can see that this has both, okay, totals equally. 1,300 supply and 1,300 demand. So this is an example of a balanced supply because the supply is equals to the demand. Okay. Now, how you would read this is that the source are in this column, and then the destination is labeled here in this row. So we have source 1, destination A, source 2, destination B, source 3, destination C, and they are actually overlapping as you can see on the matrix. Okay. And then at the bottom row, you can see the totals for the demand, and at the rightmost row, you can see the totals for supply. So bottom line is that this just shows how we plan, okay, how companies plan the sources, origin points, and the amount of supplies being carried on to specific destinations. Okay, so these will always be given, so you don't have to worry about this. The only thing that we have to do is just solve for the transportation cost. Okay, what is the efficient transportation cost? So we will do that in a bit. So let's start. And then there are, again, a lot of ways on how to solve for transportation problems. And we will cover this in the upcoming discussions. Okay. So let's go first with the northwest corner rule method. So here, northwest corner rule from the term itself, north and then west, a method for computing a basic feasible solution of a transportation problem where the basic variables are selected from the northwest corner. Again, originating from the term, meaning the top left. Okay, so if you have a grid or a matrix, you will always start at the top left corner, which is this one. Okay, top left or northwest. Okay, and then northwest corner rule method has the following steps. Okay, so first you have to find the northwest corner cell, allocate as much as possible to that selected cell, and adjust as associated amounts of supply and demand by subtracting the allocated amount. And then reduce the available supply at the corner origin and unsatisfied demand at the current destination by the amount of allocation. Number three is to identify the first source with available supply. This is either the current source of the one directly below it. Number four, identify the first destination with unsatisfied demand. And number five, allocate as if it's in step one. So it is just a cycle basically. So to further understand this, let us elaborate this with an example. Okay. So we have a tabulated transportation problem wherein we have sources or origins planning to deliver to several destinations such as A, B, C, and D. And then outlined here will be the supply and then the demand. Okay, totals for the supply and the demand. And then what we can make out of this is that this is a balanced example. Okay, balanced because we have the total for supply and demand equaling to 1,300. So now let's start. Okay, first what we would have to do is it says here, sorry for the typos, find the northwest corner cell of the transportation tableau. So we go with the northwest corner cell, which is this one, okay, number 8. A, source 1, destination A. So let me explain what happened here, okay? Earlier, we have 325 total demand and total supply of 400 pieces if we are going to locate this region, source 1, destination A. And then what happened is that whichever is the lower in terms of amount, let's say 400 and 325, that is going to be the amount that we will plot in the northwest corner region. So here, What we did is we copied 325 in the northwest corner region, thus we have NWCR, okay, reduce the available supply at the current origin, okay, and put it in the northwest corner region. So if you will do this handwritten, you can just simply write a box on the upper left side and then put in the amount. Again, why did we choose 325? Because it is lower than 400. And then 325 minus 325 is 0, thus it's cancelled out. And then 325 minus 400 leaves us with 75 remaining supplies. Okay. And then what happens next is that we will cancel this entire column because we have already exhausted the demand here. So there is already no demand left for this column. Okay. So next. So next what we did is we go to the next block, which is source 1, destination B. Okay. So what happened here is that earlier, as you can see, we still have remaining 75 pieces of supply. And then what we did is we plotted it here. Okay, so why did we choose 75 over 425? So again, you would have to choose the lower amount. So between 425 and 75, we will choose 75. Thus, it is already plotted here, 75, and then 75 minus 75 is 0, so it's cancelled out. And then 75 minus 425 gives us 350. Okay, so since the supply here is already exhausted, meaning there's none left, what we're going to do is cancel the entire row. Okay, so we have canceled that entire row. And then we will go back to the same process as step 1, which is to identify the left northwest corner region. So here, sorry, rather not step 1, but in this essence, we will identify the first destination with the unsatisfied demand. So we see here, we still have 350. This one is canceled out. Okay, so we will put 350 here. So why did we select again 350? It's because 350 is, sorry, lower than 500. Okay, so we transferred 350 here in the northwest corner region. 350 minus 350 is 0, so it's cancelled out. And then 350 minus, 500 minus 350 is 150. So here is the plot. This one is already exhausted and we still have 150 pieces supply. Okay, so we do the same step. Okay, we cancel this out. Okay, this entire block. Why? Because again, it is already exhausted. And then earlier, we still have 150 left here. Okay, so 150, we transferred it again here in the northwest corner region because 150 is lower than 475. So 150 minus 150, it's zeroed out. Okay, and then 150, 475 minus 150, you get, or you have 325 demand left. Okay, so this one is already exhausted. So next, we will have to cancel this. Okay, in there, it's already blocked out. And then what we did is we repeat again the cornering method step, which is going back to step 1. So step 1 repeated. So we transferred 325 here because 325 is lower than 600. Okay, and then 325 minus 325, it gets canceled out. And then 325 or 600 minus 325, you will have 275 left. Okay, so this one is exhausted, so we will block this out. And then what we did is that we have 275 supplies left here, okay, in the rightmost column. So what we did is we copied it here, but we have 275 at the bottom as well, if you would remember this one. So what happened is that 275 minus 275 is 0, and then 275 minus 275 is 0 as well. That's why we no longer have demand and supply remaining. Okay? And that with that, we will already close the entire matrix. And we were able to plot the northwest corner regions of our problem. Now, one thing remains, which is for us to compute for the transportation cost. So we can simply add and multiply the numbers here. Okay, so transportation cost is 325 times 8. So where did we get that? We get that here, 325 times 8. Again, these are given the requested demands and supply. So you don't have to worry about that. You just need to multiply whatever it is you have plotted during the entire process of the NCWR method, NWCR method rather. So 325 times 8 plus 75 times 6 plus 350 times 11 plus 150 times 10 plus 325 times 8 plus 275 times 7. Okay. So when you do all of these things, you should arrive at the transportation cost of 12,995. So that is the amount that you need to prepare in order for you to be able to deliver, okay, transport all of these supplies to all of these locations coming from three different sources. Okay, so I hope we were able to understand this. And with that, I'm going to give you this assignment, which is to solve for the transportation cost using the Northwest Region Corner method as well. So everything else here is given. We just need to follow the steps that I have outlined in the example. Okay, with that, thank you so much. I hope you have understood this lesson. And again, if you have questions, feel free to send me a message, and I will see you on the next lecture.